Alright, we're going to wrap up the trig equations for now. So let's solve this equation. First, let's do it over this domain, and then we'll do the general solution. So for part A, we would go cos x minus 6 equals 4 cos x minus 4. If I collect like terms, I end up with 3 cos x equals negative 2. And so cos x is negative 2/3. Cosine is negative here and here. If I figure out the reference angles, I'm going to take the, does it say? Yeah, it says radians. So let's put it into radians. 2 divided by 3 second cos. Oops. So the reference angle is 1.231. And if I look at the domain, I can go from negative pi by 2 all the way to 3 pi by 2. So you can see where my two angles are going to be. They're going to be here and here. Okay, so x would be, if I go pi, take away that reference angle, I get 1.911. And then if I add pi, I get 4.373. Looking at the general solution, all I need to do is take those two answers and add 2k pi to them. Okay. Really nothing different here. Let's try this. Again, we'll do A and B. So cosecant x is going to be 5 over root 2. Sorry, negative 5 over root 2. So sine x is going to be root 2 over 5, and it's negative. So it's going to be the reference angle if I go root 2 divided by 5, so the reference angle is 0.0, oh, it's in degrees. So we gotta do that over again. So 14 degrees. So I'm allowed to have answers from negative 180 to 180. So I can have that. You can see there's no answers there, but there are two going this way. So my solutions will be negative 14 degrees and negative 166 degrees. Okay, and you could go and figure out what those angles are positive, but the easiest is just to say negative 14 plus 360k and negative 166 plus 360k. By the way, what happens if you miss a degree symbol? Costs you half a mark. Okay, you have to be pretty particular. All right. The only reason I want to show you this one, you've seen one like this, is be careful with the factoring. If I want to factor this, easiest way to do that is to look at perfect squares. So if I take the square root of both sides, I get plus or minus the root of 1, which is 1 over root 2. And so this is going to be in all four quadrants. The reference angle is 45 degrees. So the actual angle is going to be 45, 135, 225, and 315. All right, last one. Question from hell. All right, when I first started teaching this, I thought, well, there's no way you're ever going to get a question where you can't factor this. Okay? And then 1 year on the exam, there was a question that couldn't be factored. Okay, let's quickly look at it first of all and try to figure out, how do I know if it can't be factored? Okay, so I'm going to bring everything to one side of the equation. So 3 cos squared plus cos minus 1 equals 0. And so you're going to say to yourself, all right, I can factor this. And you might get stuck. Do you remember how to tell if something can be factored or not? Do you remember b squared minus 4ac, the discriminant we called it? If you take the discriminant in this case, what do you get? You're going to get 1 plus 12. This is 13. All right? This means cannot be factored. Okay, it does not mean that you can't find a solution. It just means you can't factor it. Okay, what are we looking for here? Just as a reminder, if it's a perfect square, if the discriminant is a perfect square, that means you can factor it. Okay, but this one can't be factored, so we can't do this. Do you remember what to do with a quadratic equation that can't be factored? You have to use the quadratic formula. Okay, and if you remember, the quadratic formula is x equals negative b plus or minus the square root b squared minus 4ac over 2a. This is the quadratic formula. It's actually on your formula sheet, which should be a hint that you will need to use it. Now the only difference is we're not going to solve for x. We're going to solve for cos of x. That's what the quadratic formula will be used for in this case. So you'd have negative 1 plus or minus. Now I already know this is 13. I already figured that out. Over 2 times 3. Okay, so you get cos of x equals negative 1 plus root 13 over 6, and you get negative 1 minus root 13 over 6. And what we need to do is solve for both of those. Okay, so let's figure out what the first one is. So you're going to have negative 1 1 the root of 13 All right, so the first one I think is 0.434. Okay, and we know that's positive. Cosine will be positive here and here. So let's quickly figure that out. What is the reference angle going to be? .122. So we're going to get 1.122, and we're going to get 5.162. Okay, now let's try the other one. Cos of x equals, so we're going to take -1 take away root 13 divided by 6. All right, and that's going to be negative 0.767. Well, we'll put 8 dot dot dot. It goes on for quite a while. And here, going to be negative. So what's my reference angle? It's going to be 0.696. And so if I take away from pi, I get 2.446. And if I add pi, I get 3.837. All right, that's a really tough question. It's a very tough question. And in fact, we didn't solve it for negative pi to pi. We actually solved it from 0 to 2 pi. Okay, if we had to do from negative pi to pi, it would be a little bit different. The general solution, we're just going to add 2k pi to each one. Okay, so that is the end of trig equations for now. Lots of questions for you to try. I'd like you to do all of these, get caught up, because we're going to start identities on the next lesson, and I need you to be prepared for that. So finish the trig equations, make sure you're feeling comfortable with those.